All right, now let's get started. So yeah, today's gonna be a bit more, I guess, lecture intensive because we have a bit to cover, little bit more than usual to cover. So yeah, let's just get started with it. So linear and quadratic systems. So what are linear and quadratic systems? They're like systems of equations, except instead of having, say, two linear equations, you're gonna have one linear equation and one quadratic equation as a system. So for example, you have like y equals to x plus 1, which is linear, and y equals to x squared minus 1, or in the case of the graph on the right, y equals to x squared minus 2 and 2x plus 1. So on the test, you're expected to find solutions to the system like the one shown, well, not above, to the right, either algebraically or graphically. In this case, you're provided a graph, so you're supposed to find solutions to the system. So identifying solutions to linear and quadratic systems from graphs. So a linear and quadratic system can be represented by like a line or a parabola, which is, as I said before, a linear or quadratic equation. And each intersection of the line and the parabola represents a solution to the graph. So for example, let me just get my annotation. So for example, this and this are solutions to that systems of equations. And yeah, so for example, the system graph to the right has two solutions: -2x, -2 comma -2, and 3 comma 3. A line in a parabola can intersect 0 once or twice, 2 times, which means a linear and quadratic system can have 0, 1, or 2 solutions. And here's an example of each one of those situations, I guess. So solving a linear and quadratic system algebraically. So the goal when solving systems of equations is to reduce two equations with two variables down to a single equation with like one variable. And since each equation in the system has two variables, one way to reduce the number of variables in the equation is to substitute. As like we've done in a previous lecture, you have to substitute and I guess just like plug in stuff. So it's the same thing. Instead, the only difference between a linear, I guess, systems of equation problem and a linear and quadratic systems of equation problem is that one of them is going to be quadratic. So in for this, in the systems of equations, both of the equations are simultaneously true. In other words, like one equation tells us that y is equal to x plus 1, and the y in the second equation is also equal to x plus 1. Therefore, we could plug in x plus 1 as a substitute for y in the second equation, as is shown right here. So, and then from here, you just solve the equation for x, and this gives us the x values of the solutions to the system. And then we can use the x values and either of the equations, x plus 1 or x squared minus 1, to calculate the y value. So to solve a quick summary, to solve a linear and quadratic system, so you have to isolate one of the two variables in one of the equations. And in most cases, isolating x is easier because the problem is given in a way that like it's easy to manipulate the equation to get to get y. Then you have to substitute the expression that is equal to the isolated variable from step 1, which in the previous problem was x plus 1, and you just substitute it for y. And this should result in a quadratic equation with only one variable. In that case, it was x. And then you solve the resulting quadratic equation to find the x values of the solution. And then you just substitute whatever you get for x into either one of the equations. Again, you can substitute into x plus 1 or x squared minus 1 to get y. And with that, you get like solutions to the graph. Someone asked me to put the link to slides again. That should be the link to today's slides. All right. So this is a practice problem. I'll give you guys like 2 minutes to do this, and then I'll solve it with you guys, I guess. I'll give you guys a minute to do this problem. course, if you guys have any questions from what I just said, just, I guess, raise your hand or put the question in the chat. Another 30 seconds, and then I'll do this problem. All right. So what did you guys get? Just like put it in the chat. So yeah, so I can tell if people got the right answer. All right, so you guys should have gotten C. And the reason for this is I guess the linear line and the quadratic line. So the linear line right here and the quadratic line right here intersect at 2 points, which is respectively, this one is I, or which is 1, and the other one is 3. And therefore the answer is C. The reason 2 isn't true is because at this point it's only the vertex of the parabola and it's not intersecting with the linear line. All right. Here's another practice problem. I'll give you guys a minute to do this one as well. All right, give you guys another 30 seconds. All right. So for this problem, first thing you do is you isolate this first equation for y. So what I did was negative y equals to 3 minus 3x. And then you divide by -1 because that gets rid of the negative signs here. So that becomes y equals to 3x minus 3 because this negative cancels out and this one gains a negative because of that. So you have that. And now since you know that both this and this are equal to y, you can replace this. You can substitute this into any y there is. So you have 3x minus 3 equals to x squared plus 6x minus 7. Now you combine like terms. So you take the 3x, you subtract x here, subtract x here. You want to get 0 on this side. So you want to get 0 equals to something. So you do that, and then you get like -3 equals to x squared plus 3x minus 7. You add 3 on both sides, and you get 0 equals to x squared plus 3x minus 4. And from there, you factor this problem. So a way of factoring you try to factor it into x plus a times x plus b. So a way of like getting a factored term is that you need to know that a plus b has to equal to 3 because that's what it is here. And ab has to multiply out to -4. So whenever you need, I guess, the terms of a factor, you have to make sure that the two numbers that end up being factored add up to the middle term and multiply out to the end term. And in this case, the two factored terms would be x plus 4 times x minus 1 equals to 0. And that is the same as x squared plus 3x minus 4. And now we need to find out what makes this equal to 0. And there's two different answers that could do that. X plus 4 equals 0 and x minus 1 equals 0. So, and then that you subtract 4 here and you add 1 here. So you have x equals to -4 and x equals to 1. And now you need to just calculate, I guess, the y terms. So you have 3x minus y equals to 3. So you plug in 3 times -4 minus 4 equals to 3, I believe. Or wait, what am I doing? You get the isolated term. So you have y equals to that. So you have y equals to 3 times -4 minus 3. And that turns into -15. 3 times -4 is -12, minus 3 is -15. And then for the other one, you still plug in y equals to 3 times 1 minus 3, which is 0. And so now that you know that when x is -4 and y is -15, and when x is 1, you know that y is 0. And the only answer that matches up is A. Does anyone have any questions? For the person who's asking to explain the previous problem, I'll do that after I explain this one to the people who have doubts. Last week though?
Yeah, so when you got -4 and +1, you have to put those back into which equation? The original one or like the one that you came up with?
What do you mean? When I got x equals to -4 and x equals to 1?
Yeah.
So I plugged it into the one where I substituted for y. You technically could just plug it into this one.
Okay.
However, then you're gonna have to do a couple more steps of math, and it's just easier just to plug it into here because it's already done, I guess.
How did you get that equation?
Which one? Y equals to 3x minus 3?
Yeah.
So as I said here, so I did I subtracted -3x from both sides because there.
Okay.
And then it's -3x plus 3, and then it divided the whole thing by -1 to get rid of the negatives on here.
Okay.
And that turns it into 3x minus 3.
Okay. Did you do the same thing to the equation under that or no?
No, because that one already has y isolated.
Oh, so you were just isolating for y?
Yeah.
Oh, okay. Okay. That makes sense. Thank you.
Mm-hmm. Karen?
I'm a bit confused how we got -4 and -15. For
Mhm.
my solution, I got 1 and -4.
What?
For my solution, I got 1 and -4 instead of.
So I guess I can walk you through the steps. So I guess, did you isolate for y in the first place? I guess.
Yes,
Why?
I did everything until I got x equals -4 and x equals 1.
Okay, so then that could have been a problem with like what you factored here.
Okay.
So remember, I might have explained this a bit badly, but so it's actually not 4, I guess, here. So basically A in this case is equal to 4 and B equals equal to -1
Mhm.
because 4 plus -1 is 3 and 4 times -1 is -4, right?
Yes.
So you plug in x plus 4 and then x minus 1. So your two solutions would have been x equals to -4 and x equals to 1 because you take whatever one of these factors is, you set them equal to 0 because if either one of these equal to 0, the whole thing equals to 0 because you're multiplying.
Yes.
So then you should have gotten x plus 4 equals 0 and x minus 1 equals 0. And
Yeah.
then x would have been -4 or x equals 1 to make these equations true, I guess.
Yeah, and that's what I got.
So you got -4 and 1.
Yes.
And that is not the answer because first of all, these both are x. That is y here.
Oh, so we're solving for y's instead of x's. Okay.
So you
Thank
need both x and y. And that's why I went back and plugged it into this equation because I'm trying to get y and it's a lot easier to plug it into this one than this one.
Okay, I read his question as finding two x's instead of finding x and y. Thank you.
Mhm. All right. Extra.
I have a question about how you factored x squared plus 3x minus 4.
All right. So, what is your question really?
So how did you factor that?
So, as I said, so a way of doing this, so basically you have x squared plus 3x minus 4, right?
Mhm.
And you need to make it into x plus a times x plus b form, right?
Mhm.
So the rules for this is that a and b have to add up to the middle term. So you need a plus b equals to 3. And then a times b has to equal whatever the last term is. So -4.
Oh, okay. I get it. I think
And
I
then
get
from
it.
there, you just solve for a and b.
Yeah.
All right. Shreya, one sec.
So when you're plugging in the x values, where did you get 0 from?
So when you have nothing there, that just means 0, right?
Mhm.
So that's what I did. I basically made it so that there's nothing there from on one side.
Okay, and when you find x like -4 and 1, so when you
Mhm.
plug it into the equation 3x minus 3, so when
Mhm.
you plugged in 1, you got 0, but the answer is -4. How did that happen?
So look, so what happened is you have x equals to -4 here, right?
Mhm.
I plugged it in, I got -15. All right. So
Yeah.
for my next one, I put it in 1 and I got 0. And none of these answer choices has y equals to 0. Therefore, I can just ignore whatever x is 1 is for. Whatever, I can just ignore x equals to 1 and focus on x equals to -4. And I know that x equals to -4 and x equals to -15 are the answer, and A has those answers, I guess.
Oh, okay. Thank you.
All right, so how did I get x plus 4 and x minus 1 after isolating? So again, that's a rule of factoring. So as I was saying, the rule is so when you have x plus a times x plus b, a plus b has to equal to the middle term, and a times b has to equal to -4. And therefore, a is equal to, I believe, 4, and b is equal to -1. And I just plugged them into this. And that's where I got my factor. Side, do you get that? Or could you just like raise your hand so I can unmute you and you can ask your question. I didn't explain it entirely. All right. So there were people asking for the previous question. I'll quickly go over that again. Here's the link to the slides for the people who are asking. All right, so for this question, I guess, so a solution to, I guess, a systems of equations graph is where the two, I guess, equations connect. So in this case, 2, 3 and 8, 9 connect, and therefore our answers have to include those two. And the only answer that works, I guess, is 1 and 3, and C is the only one that has 1 and 3. Do you get that, Shreya? All right. Moving on. So what is like isolating quantities, and how frequently do these like questions occur? So this type of question, I'm pretty sure occurs like as a question as in and of itself, it occurs like once or twice. However, as we saw in the previous question, you're gonna need to know how to isolate quantities, because a lot of questions have that as a part of the way of solving it. So what is like isolating quantities? So many real world scenarios can be described using equations and formulas like with multiple variables. For example, the formula for an area A of like a rectangle of length W and a width of W, a rectangle with a length L and width W is A equals to length times width, which is just the equation for the area of a rectangle. And in this form, A is isolated because it is by itself on one side of the equation. If you wanted like the equivalent equation, but with like L isolated, we just divide both sides by W to get L isolated with A over W. So isolating quantities is pretty similar to solving equations. However, instead of like ending up with a variable equal to like a number or a constant, we end up with a variable equal to like multiple variables in an expression. And in fact, like you've probably, if you've like rewritten x plus y equals to 1 like slope intercept form, you're isolating for y, as we were doing in the previous questions. And the most important thing to like remember is that a rearranged equation will always remain like equivalent to the original equation if you treat both sides equally. So when you add 1 to one side, you have to add 1 to the other side as well. You can't just add 1 to one side and just like add 2 to the other side. That is not mathematically correct. So to isolate an equation or formula, you write down the original equation if needed, and or you translate the word problem or like give context for the equation. You perform the same operations on both sides, like whether it be +1 or -2 or whatever on both sides to keep it equal. And then you just divide a variable off, and you repeat that until you get like whatever variable you want on one side by itself. So here is, I guess, a practice problem. I'll give you guys a minute to do this one. Another 30 seconds. All right, what did you guys get? Just like put your answer in the chat. All right, it seems like most of you got the right answer, which in this case is C. So the way of solving this, you're given I equals to P R T, and you're trying to find whatever P is in terms of every other variable. So you need to find P equals to blah, blah, blah. So the way of doing this is you have I equals to P R T. You divide RT on both sides because that's how you isolate for P. And you just do P equals to I over RT. So is anyone confused why it's not that? Because people were putting A as their answer in there. Okay, so for this question, so you're given the equation I equals to P RT. And what you want is to have P equals to something. And the easiest way of doing this is just to divide R and T on both sides, because again, when you do something on one side, you're supposed to do it on the other side as well. And when you do that, you get P by itself, and you have I over RT, because that's what happens here. You cancel out these, and you're just left with P equals to RT, I over RT. Although I'm just gonna quickly rewrite that so it looks better. P, and then you have I equals to RT. Well, technically, you don't have to read the entire question. However, sometimes they're going to have like a trick question in there or whatnot, and it's probably better to read it. All right. Does anyone else have a question on this problem? All right. No. All right. I'll give you guys a minute to do this one as well. And for the people who are asking now, here's a link to today's slides. I will get last week's slides sent 1 second. All right, this is last week's slides for the people who are asking. All right, another 30 seconds, and then I'll do this question. All right. So there's a link for to find out where to get the previous classes I guess recordings. However, we only have until class number 7. We will probably get 8, 9, and 10 in this week. But that is the link for all of the classes up till 7, and we'll probably get it the rest of them in this week. So what we're trying to do is we're trying to get, so we're given the formula F equals to G M1 M2 over D squared. And we're trying to get D equals to something. So first thing we do is we multiply both the bottom, both of the sides, I guess, by D squared, because we don't want D in the denominator. That just makes stuff harder than it should be. So you have D squared times F equals to G M1 and M2. These two cancel out because you're multiplying when it's under. And from there, you do divided by F, because we want to get F on the other side. We want D by itself. So you have D squared equals to G of mass 1 and then mass 2 over F. And now you do square root to get rid of this, because we want D by itself without anything else. So you have D equals to G M of 1, M of 2 over F. Oh, and the whole thing square rooted. And that would be D. Does anyone have any questions on it? Just raise your hand or put your question in the chat if you're confused. All right, no questions? Okay. All right, so the next thing we'll be reviewing is function notations. So what is a function? A function takes an input and produces an output. In function notation, f of x, in the function notation of f of x, f is the name of the function, x is the input variable, and f of x, when it's all combined, is the output. So for example, you're given f of x equals to 2x plus 1. The expression 2x plus 1 works as like instructions on what to do with like whatever you put in for x. In this case, the input x is multiplied by 2 and then added, then you add 1 to it. So for these types of questions, you'll need to know how to evaluate functions algebraically, determine inputs and outputs using tables, evaluate composite functions, and compose two functions, I guess. And there's an image on the right, which basically tells you what I just said out loud. Shruti?
Hi, so approximately how many questions do you think will be in the SAT of the isolating quantities and this function notation?
So isolating quantities by itself, I'd say maybe 1 or 2 max. However, isolating quantities, as you saw in like linear and quadratic systems and other stuff, is going to be used a lot simply because it's like an underlying, I guess, subject for many different ways of solving equations. So I wouldn't pay attention to how many questions of isolating quantities there are. However, for function notation, I'm pretty sure there's like 2-ish problems per SAT, maybe a bit more.
Okay, yeah, thank you.
All right, so evaluating functions algebraically and using tables. So when we encounter like an algebraic function, we find the value of the function at very specific outputs. For example, you have f of x equals to 2x plus 1, and we can calculate f of 2. The output of the function with input x is equal to 2. So in this case, you plug in 2 to it, so you get 2 times 2 plus 1, which is 5. And then you just perform as I said in the next bullet point, you evaluate a function at a specific input value by plugging in that value wherever it appears and performing the operation specified by the function to calculate the output. Depends for calculators. Some questions are going to be a little bit more, I guess, mathematically tough to calculate without a calculator, and you might have a calculator to use then. But these types of questions could be either no calc or calc. There's no real like defining line for it. So yeah, with algebraic functions, we can evaluate the function using multiple inputs to create multiple input output pairs. And this is like shown in the graph for f of x equals to 2x plus 1. For x equals to 0, f of x is 1. For 1, f of x is 3, and so on. Sometimes like a table is provided without an algebraic function, like the table x equals to negative g of x is equal to 7 when x is negative 2, g of x is 0 when x is negative 1, and so on. The table contains 4 input output pairs, and we can interpret the table as there. And to evaluate a function using a table, you find the input value you're looking at in the input column, typically the left column with the header of an input variable like x or z or y or whatever. And you find the corresponding output value in the output column, which is like g of x, h of x, f of x, stuff like that. So composing functions. So this is when you input expressions instead of values into functions. So before you're saying x equals to 3 and you're putting in whatever you're putting in the number 3 into your function. Now what we're doing is we're taking another function. So as it says, as I wrote here, you have for example, you have f of x equals to x squared and g of x equals to x plus 1. F of g of x basically replaces all instances of x within f of x, so right here, with whatever g of x is, which is x plus 1. So it'd be f of g of x is in this case x plus 1 squared, because you're taking whatever g of x is and you're putting it into wherever x is mentioned in f of x. The function can also be defined in terms of another function. For example, f of x equals to x squared and g of x equals to f of x plus 1. You replace the f of x in the function with x squared because that's what f of x is. So you get like g of x equals to x squared plus 1 instead of g of x equals to f of x plus 1. These are functionally the same thing because f of x is equal to x squared. And if you find yourself like struggling to rewrite complex functions, you probably will need to like brush up on like operations with polynomials. This part I got from Khan Academy. Oh, they have really good lessons for all of these. And yeah, so to compose two functions, you plug in the expression that defines the inner function wherever the input variable appears in the outer function. So it feels like g of x, g of f of x, you plug in f of x wherever x is in g. Or if it was f of g of x, you plug in g of x wherever x is. And then you just perform the operation specified by the outer function and just combine like terms. So I'll give you guys a minute to do this practice problem, and then I'll do it myself. All right, another 30 seconds. All right, what did you guys get for the answer? All right, so it sounds like the people who did put the answer in the chat got it right. So what this is asking us to do is basically you want f of g of f of x, which is equal to, you could replace x with f of x because that is what we're putting in there. So f of x cubed, and that is the same as g of f of x equals to x cubed plus 3x plus 7, all of it's cubed. And that is B. Does anyone have any questions about this? No? All right. Here's like a separate problem that I just thought of. So what would you do if you had f of g of x? Try solving that. I'll give you guys a minute to do this one. And just like put your answer in the chat after you finish. Oh, and it's not really going to be in here. Don't just ignore all of this. Just like put your own equation. Ignore all of this. I'll give you guys another 30 seconds to do this. All right, so there's like two common variations of this equation that you guys answered. And I know where you guys got it wrong as well. So you have f of g of x equals to basically g of x squared plus 3 times g of x plus 7. You replace g of x with x cubed at all terms. So you have f of g of x equals to x to the third to the second plus 3 times x to the third plus 7. Remember, when you raise an exponent to an exponent, you do 3 times 2 because you're raising it to an exponent. If you were doing x to the third times x to the second, then you would add that up to 5. Because when you're multiplying, you add them up. When you're doing an exponent of an exponent, you're multiplying. So you have x to the 6th plus 3x cubed plus 7. So do the people who answered x to the 5th plus 3x squared, 3x cubed plus 7 get why it's not that? Also, so no, it would not be x to the third equals to x squared plus 3x plus 7 because you're not replacing f of g of x with whatever g of x is. You're just plugging in g of x into wherever x is. So does anyone have any questions for this one? Oh, Lost Rita?
Do you mind going over the original problem, please? I got a little bit lost.
All right. So the original problem, basically, you want to find out whatever f of g of x is, correct?
Mm-hmm.
So in this, that is the same as, since you're plugging in f of x instead of x here, you replace all instances of x with whatever f of x is. So you have x squared plus 3x plus 7 whole cubed. And that is an answer, B. Do you understand why?
You made it a whole cube because I don't know. Yeah, I don't understand exactly why it's like cubed.
Oh, because look, so you're replacing only the x. You're not replacing whatever it's raised to.
Okay.
So think of it this way. So you have x g of x is this basically, right? G of x is this in Google Docs or whatever. All right. Just you want to isolate x and you want to replace whatever x is with whatever f of x is because that's what you're plugging in. So then you have all of that in there to the third.
Oh, okay. I see. Okay, so basically, the g of x, so the x is like all of the x squared plus 3x plus 7, and then that's raised to the third.
Yeah, because you don't replace the third as well. That's just there.
Right, okay, that makes sense. Thank you.
All right. Veda, do you understand now, or do you want me to do another problem? I'm pretty sure the next problem also does stuff like that. No. All right. So I'll give you guys a minute to do this problem. Also, did the people who are answering something different from what I got understand why I got what I got and not whatever you guys got? Just like put it in the chat if you do, or if not, just say I don't and I can go back and review it. For clarification, I meant the one that I made up on the spot and not the one that was on the slide. Like the reverse of it, it was like f of g of x instead of g of f of x. Because I saw a couple of people got that wrong. Right, another 30 seconds and then I'll do this problem. All right, what did you guys get as your answer? You guys should have gotten B as your answer. And I'll explain why right now. All right. So for this question, you have f of x is blah, blah, blah. What you want to do is you want to replace whatever x is with x plus 3. So you replace each of these instances of x with x plus 3. So you have x plus 3 squared minus 2 times x plus 3 minus 5. So remember, you can't just immediately just like square these and say it's x plus 9. No, what you have to remember is that it's x plus 3 times x plus 3. X plus 3 squared is this and not just x plus 9. All right. So when you FOIL that out, you get x squared plus 3x plus 3x plus 9. So you have x squared plus 6x plus 9 minus 2x right here, minus 6 right there, minus 5. And then when you do all of that, I guess combining like terms, you should get x squared plus 4x minus 2, and that is B. Does anyone have any questions? No questions? All right. So yeah, questions over anything we've done in the last, I guess, 40 minutes now? If not, we'll move on to practice problems. All right, I'll give you guys a minute to do this one. All right. So this one's pretty simple. The answer to this one would be B, because again, you only intersect this line and this line only intersect in one point, which is this. And therefore, there's only one solution to this equation. Anyone have any questions about that? No? All right. Next question. I'll give you guys a minute to do this one. All right. So for this question, the answer to the previous question, I believe, was B. All right. So for this question, so what we're trying to find is what is the value of h of 3? So h of 3, first thing we do inner and then outer. So h of 3 is -3. So you're left with h of -3 because that's what h of 3 is. And then h of -3 is 7. And therefore our answer is 7, which is D. Does anyone have any questions about that? No? All right. I'll give you guys a minute to do this one. For the previous question, it is 7 because, as I said here, so you have h of 3, which is -3. So you replace whatever h of 3 is with 3, which is with -3. And then h of -3 is 7. Therefore, the answer is 7. Sai, do you get that? Or if not, could you just like raise your hand so you can ask me whatever you don't understand about it. All right. Sriram?
I actually have a question on the previous slide.
Mm-hmm.
So wouldn't h of 3 be 4?
No, because remember, it's h of x. That's the output. We want h of 3.
Oh, okay.
Is that all? Or
Yeah, that's all. Thank you.
mhm. All right, I'll give you guys a minute to do this one since we got interrupted a couple times. So 1 second, I'm just gonna represent. Oops. There. All right. So for this question, does anyone else need a bit more time to do this one before we start? All right. So for this question, so you want to find out whatever r is. So you have the equation v equals to pi r squared times h. So we want to find out whatever r is. So first thing we do, you divide this entire thing by pi and h because these two are multiplied to r squared. So you have r squared equals to v times, no, v divided by, what am I saying divided? times 4 pi times h, because both sides have to be divided, and this, and these two get canceled out. And then you do r equals to square root v over pi h, because that's how you get rid of the square root. That's how you get rid of the square. So this, and then this get canceled out, and you're left with this. And our answer in that case would be D. Do you guys understand why? Or do you need another explanation? All right, no questions. Next one. Okay. I'll give you guys a minute to do this one, or 2 minutes to do this one, because I guess it takes a bit longer. Right, another 30 seconds to do this one. All right, so for this, I guess systems of equation. So you're given them both in their, I guess, y isolated form. So you don't need to really manipulate these equations any. So now you know that y is equal to 4x minus 2. Therefore, you can transfer this 4x minus 2 into the y down there. So you're given 4x minus 2 equals to x squared minus 4x plus 5. And then you combine like terms. So you subtract 4x here, add 2, minus 4x, add 2. You're given 0 equals to x squared plus 8, not plus, minus 8x plus 7. Again, so the rule is x plus a times x plus b. And a plus b has to equal to the middle term, which in this case is -8. And a times b has to equal to 7 end term. And with that, the only ones that work are -7 and -1 when you do all the math for them. So you have x minus 7 times x minus 1. And then now you set equals to 0. So you know if either one of these equal to 0, the whole equation equals to 0. So you have x minus 7 equals 0. You have x minus 1 equals 0. Therefore, our two solutions would be x equals to 7, x equals to 1, and 7 plus 1 is 8. And that is our answer. Does anyone have any questions about it? Arnav?
Wouldn't a more efficient way to be, since you already know, like, when you're doing like the middle term splitting, like, since you already know it's -8, couldn't you just do a plus b? Oh, never mind. That's what you did. Thing.
Yeah, I did that,
I didn't see
which
that.
it is more efficient, kind of, I guess, but I mean, I have it there. I just did the rest of it because it makes sense to do that. However, that is -8 and not 8, I believe. All right. Arnav, could you lower your hand if you don't have a question? Do you still have a question? I unmuted you.
No, it's just like a plus. It would be like, since it's -8, and that would mean like when you factored it, it would be x minus a and x minus b.
Yeah, and
So-
it would be, however, like it does take a leap of like logic to do it.
Oh,
So
I don't know,
I
I just-
wouldn't say do it all the time. I guess in this case you technically could because it was a bit easier. I
Well,
wouldn't say jump to it all the time, no.
But like in a real exam, like on the real SAT, like, and you don't have that much time, right? So wouldn't that be like?
I mean,
better,
it's
guess?
technically possible. However, I've never done it that way, and you might be able to do that way. However, you're prone to silly mistakes because you can somehow just think that, oh, 8 plus b is 8 -8. My answer is -8 all of a sudden.
Oh, okay.
Because you're rushing at that point, right?
Well, like
Because
usually
you're more prone to make an error when you have something like this, because it's asking for a plus b, and a plus b is -8. Ta-da, I have my answer. However, it's not really.
Yeah, but like usually the questions at the end that are like free or that aren't multiple choice, those are usually like the hardest ones. So
Not
guess that-
always, because
not?
some of the questions, some of the multiple choice questions at the end of the multiple choice section are harder than the ones at the beginning of the free response question.
Oh, okay.
That's just how it does. SAT basically gives you easier questions at the start of each section, and it progressively gets harder. So the ones at the end of the multiple choice questions are usually harder than the ones at the start of the free response questions.
Okay.
But yeah, I kind of get what you mean, what you're trying to say.
Yeah. Thank you.
Sahith?
Can you explain the part at the end where
Okay.
so after that you could get to both the x's, how do you find the final answer?
So you're given x minus 7 equals to 0, right? And x minus 1 equals to 0.
Yeah.
Right? So you add 7 here, add 7 here, add plus 1 plus 1. So you have x equals to 7, x equals to 1, right?
Yeah.
And then you just add these two because these are the two x values that you want, because a and b are both x values.
Oh, okay, I get it.
All right. Kaiser, what do you mean? Could you like raise your hand and tell me like what you mean by do the third problem again? Do you mean like third problem from the start?
Yeah, could you just like redo this problem again from like the beginning?
This one or
Yeah, this problem.
okay, yeah, because you meant this. Okay, yeah, because I saw THID in like third. All right. So you're given y equals to 4x minus 2, and you're given y equals to x squared minus 4x plus 5. So in the first problem, we had to isolate for y. In this one, we don't, which makes it faster. So you know that since y is equal to this, you can replace this bottom y with 4x minus 2. So you have 4x minus 2 equals to x squared minus 4x plus 5. And now you just combine like terms. So you subtract 4x, add 2. So you're given 0 equals to x squared minus 4x plus 7. So you want to convert this into x plus a times x plus b. Again, I probably shouldn't name them a and b. However, I'm just used to that. And you know that a plus b has to equal to 8 here, minus 8. So it has to equal to the middle term, which in this case is -8. And a times b has to equal to the last term, which is 7 in this case. So because you know that a has to well, it doesn't really matter. The two numbers that work together, I guess, is 7, -7 and -1 are the only ones that would make sense for these. And therefore your equations would be x minus 7 and x minus 1 as your x plus a times x plus b. And because this entire equation is equal to 0, if either one of these is equal to 0, the whole equation is equal to 0. So you can just say x minus 7 is 0 and x minus 1 is 0. And after that, you just solve for x. So x equals to 7, x equals to 1. And because you're trying to find what a plus b is, and a and b are both x values, you just do 7 plus 1, so you get 8. Do you get it this time, or is there still something that's bugging you about this problem? Oh, yeah, go ahead.
So could you like go over like the last bit of it? So after you get 7 or -7 and -1.
So basically what happens is you're trying to find whatever x is, right?
Mhm.
So you just add 7 here, add 7, add 1, because you're isolating for x basically. So you have x equals to 7 and x equals to 1 because you're trying to get x by itself, right?
Yeah.
And
Oh,
that is your two x values. And since you're trying to find the two x values added to each other, it's just 7 plus 1, 8.
all right. Okay. Thank you.
All right. So I'll give you guys 2 minutes to do this one. Could you lower your hand if you don't have a question? Kowser. Thanks. All right, another 30 seconds, and then I'll do this problem. All right, so for this question, so you want to find whatever h, oops. So you want to find what h of f of x is. And you know f of x is this and h of x is this. So you plug in. So in this case, you could write it as h of 3x minus 5 cubed equals 2 square root 3x minus 5 cubed plus 8. And because this is cubed and this is cube root, you can cancel out these because it's like you're raising it to the third power and then you're rooting it to the third power. So these two cancel out. So you have 2 times 3x minus 5 plus 8. And that would be FOIL. So 6x minus 10 plus 8, 6x minus 2 is the answer. Does anyone have any questions about that? No? All right, so since we are a bit, oh, well, okay, so could you isolate for x? Well, not really, no, because remember, you have 6x minus 2, but you also have h of x is equal to 6x minus 2. So you can't really isolate for x when you have this on the opposite side. Because we're just trying to find out whatever h of f of x is, and that is what it has. All right, so since we are a bit ahead of time and I didn't put in enough problems, I did find a couple more online. So this problem is 2x, whoops. So you're trying to find what x, both of the different x's are. So I'll write it down. So you have 2x plus 3y equals to -8, -8, and 3y squared minus 8y equals 2x plus 10. And you're trying to find out what the product of x1 and x of 2. So there's two solutions to this: x of 1 comma y of 1 and x of 2 comma y of 2. And we're trying to find out what x of 1 plus x of 2 is. So the two x solutions, we're trying to find out what the solution of the two x solutions are. What the the solution of the x. So we're trying to find out what the two x solutions added together is. So say x of 1 is a and x of 2 is b. We're trying to find out what a plus b is. Do you guys understand? Or so basically you're trying to find the two x's of the solution, the two x's that work in the solutions. So there's two solutions: x of 1 comma y of 1 and x of 2 comma y of 2. We're trying to find what x of 1 plus y x of 2 is. Yeah, it's like the 2x, it's like where is it? Yeah, it's like this one. It's like this question. We're trying to find what x a plus b is. All right, I'll give you guys 2 minutes to do that question while I erase all the extra markings I made. All right, another minute to do this one. All right. So, does anyone want to give tell me the answer in the chat so I can tell if people got it, or do you guys need more time? Just like say more time in chat if you guys need more time, or else just like put the answer in the chat, I guess. All right. Tell me when you guys are done. I will do this problem then. Yes, that is what the equation is. Wait, did I do something wrong? Oh, wait. Yeah, I wrote something wrong. So the question is not added, it's multiplication here. It's A times B. Sorry for the confusion. Yep. All right. So I will solve this question now. So you're given this. So first thing you can notice is that there's a 2x in both of these. So that means I should isolate for 2x in the top to plug it into the bottom. So I can, after isolating, so it's like minus 3y minus 3y, you get 2x equals to negative 3y minus 8. And then there's 2x here. So you just plug in whatever, I plug in this into wherever the 2x is. So you have 3y squared minus 8y equals to negative 3y minus 8 plus 10. And then after that, I guess you just combine like terms. So you get 3y squared minus 8y equals to negative 3y plus 2. So subtract 2 plus 3y plus 3y minus 2. So you have 3y squared minus 5y minus 2 equals 0. And now you just factor the equation and you would get, remember again, x plus a times x plus b, and a plus b has to equal to negative 5, and a times b has to equal to negative 2. And the two answers that would work is, oh wait, it's different this time. So you have 3. So there's 2 ways of doing this. I will do the, I guess, all right. So there's 2 ways of doing this. You could do the quadratic equation to get the factors, or you just factor it normally. You just try to find out like what could multiply out to this. So you know that it's going to be 3y plus or minus something, and you know it's y here, and this entire thing equals to 0. So 3 times what plus what would equal to 5. So 3 times, I would say, plus 1 and then minus 2. 3 times negative 1 plus 1 would be 5. And 1 times negative 2 is negative 2. And with that, I get, so I know from there, if either one of these is 0, the whole thing's 0. So 3y plus 1 equals to 0. And y minus 2 equals to 0. And from there, it's 3y equals to negative 1 because you subtract negative 1 on both sides. And then you divide the whole thing by 3. And then for this one, you just add 2. So you know that y is equal to negative 1/3 and y is equal to 2. And because we know that, you just plug in y into the first equation. So if 2x plus 3 times negative 1/3 equals to negative 8. And that solves out to, so you just do 3 there. So 2x plus minus 1 equals negative 8 plus 1 divided by 2 x equals to, I believe 7/2. And that is one of your x solutions. And then you plug in y equals to 2 again into it. So you have 2x plus 3 times 2 equals negative 8. So 2x plus 6 minus 8. So subtract 6. So you have 2x equals to 14 or negative 14, I believe. And then you have x equals to negative 7. So your 2 x solutions are x equals to negative 7 and 7/2. Negative 7/2, sorry. And then when you multiply negative 7 times negative 7/2, you get 49 because 7 times that it's just 49/2 because I guess, yeah, that should be what it equals to, and that is your answer. 49/2. So this one, it requires a lot of calculation. Although I'm pretty sure parts of this can be done in your head. It would be better to just do this in calculation. What can you do with, wait, what do you mean? Could you just like raise your hand and tell me what you mean by, can't you do this with two equations? All right, does anyone not understand what I did? I can do this again a bit more neater now that I actually solved it. Ayush?
So like, can you plug in like 2 or something? You have to plug in 2 and -1/3 into the same equation, into like one of the
Well,
equation.
you could plug it into the two different ones. However, I feel like plugging into the second one, which has an exponent in there, would be a lot harder than just plugging into one without an exponent.
So you can't plug in like 2 into the first equation and then -1/3 into the second, right?
You can, because they're equal to the same thing.
Oh, because both the equations are equal to each other.
Yeah.
Oh, okay. Thank you.
Does anyone have a question about this problem? I can do it again if you guys do. All right, if not, that would be it for today's questions. I guess next class, we're gonna do a humanities passage as well as just like more grammar practice. Oh, the answer was -49/2, I believe. No, it's not negative, just 49/2. And yeah, that's it for today's class, really. If you guys have any other questions, I will stay behind for another 5 minutes. Just like raise your hand and ask me a question. Other than that, have a nice Easter, I guess. Good luck on your ACT, Satya, if you're still here, I guess. Unless you have a question, then I can answer it, I guess. Bye. All right, so Ayush, the thing with internships is that so internships tell colleges that like you have work experience and that you can actually work in an actual field. I'm just gonna stop the recording.